Hi guys. So, welcome to technically the second episode, but I'm gonna call it the first because I'm not gonna post the first one that I recorded. It was about fractional exponents, and it was 25 minutes long, which wasn't the problem. You guys probably wouldn't watch the whole thing, but I don't care, cause yeah, but I didn't turn on my mic for that, so it was kind of really silent the entire time, and it's boring, and you guys probably wouldn't even watch a minute of that, cause yeah. But anyways, I'm doing this. Oh wait, oops. I'm doing this thing where I'm gonna be like filming videos of me like solving math problems, cause like I started to like read I should probably charge my iPad. But anyways, I started to read like my textbook because I'm gonna be taking the AC10, which is a prestigious math competition thing. And okay, this is a really bad charger. Well, it's not long enough, and that's a problem. Okay, well, anyway, I wasn't feeling productive, so I started to read my textbook to be productive, because I don't even have homework, actually. Actually, I do, but, like, it's not due until, like, 2 weeks, because they're both projects. Well, one of them is due this Friday. Okay, but anyway, I started to read the textbook. It's called Volume 1, The Basics from the Art of Problem Solving, and it's a really good book for preparing for the MC10 because it has a bunch of theorems that you wouldn't learn normally in a school curriculum because it's not really needed, but it's like a faster way of solving math problems. And I need a burp. Give me a moment. Okay, it's gone. But anyway, it gives you like a bunch of theorems and stuff and whatever, and I still need to buy volume 2, but the test is in about 2 months, November 8th, and I am so excited. But anyway, I haven't been studying lately, which is why I decided to film these videos to explain to you guys the math stuff. And also, this is like a study technique. It's called Feynman's. You guys know Richard Feynman, the little physicist guy. Wait, let me search up his technique so I can read you guys the definition. But anyway, it's pretty much just teaching a concept, and then by teaching the concept, you like run into gaps in like your explanations and teaching and stuff, and therefore you identify the stuff that you need to work on, and that's active studying, which I made a presentation on like a bunch of studying methods, but I don't think I ever finished it. Actually, I think I did, but like no one wanted to see them, so I didn't present it to anyone. Oh. No, I just didn't finish, but Feynman technique, that's what it's called, and it's really awesome. Also, active studying pretty much just means you're engaged in the topic, you're paraphrasing, you're using like your mind instead of like, so passive studying would be like reading a textbook, but you're not like you're not really understanding what it's saying, and you're copying down exactly what the textbook says. So that's just like, so when you're like reading something but you have to like reread it because you didn't know what it said, that's pretty much passive studying, but reading form, I guess. Well, technically it'd still be studying since sometimes you read to study. Okay, but anyway, that's what it is, and that's what I'm doing, and that's why I'm filming these videos. I don't know if you'll find them helpful or not because I'm not really good at explaining stuff, and I do some math in my head that's not really explainable. Wait, I need a hair tie, but anyway, we're gonna be doing simplifying radical expressions, except it's gonna be harder than the stuff you learned in algebra because this is competition math, not school math. Anyways, also, I'll explain like the pathway of the AMC10 stuff. Maybe I should make like a separate video on that because it's kind of cool. But anyway, first problem we have, let's go to the basics because, maybe you guys forgot and I low-key forgot too. So let's do the square root of 8. This is problem number 1. So to simplify a radical expression, you have to find the factors of it. So it'd be like square root of 4, square root of 2, and we already, so that means, oh wait, let me guys show you a simple rule if you guys didn't already know already, but if you have two radicals and you like multiply them, actually let's not do that because, okay. If you have two radicals, when you're multiplying radicals, you just multiply the number under the roots. So that would be the square root of 8 times 7, which is this. Okay, so that's why this simplifying stuff works. Anyways, you can simplify this down more because the square root of 4 is just 2. So that means 2 times the square root of 2 is what it equals, pretty much. Yeah, I don't know if you guys understood that or not, but it made sense to me, so I don't, oh wait, I should not erase that. I'm gonna just put it in the corner in case you guys need it or something. It's not like I'm gonna send you a PDF of this though, so. Actually, maybe. Like, if you guys actually want me to, but I doubt it. Okay, next problem, square root of 96. So we have, I think it can be divided by 3. 3 and 32. That would be, since this can't be simplified any further, you just leave it there. This is square root of 8 and square root of 4, and this is 2. So now you just multiply the remaining stuff, because right now it's actually, what we're doing is square root of 3 times square root of 8 times square root of 4, because this is just the square root of 32. Let me rewrite that so you guys can see it better. So the square root of 32 is technically, what is it? Oh, 8 square root of 4 times square root of, yeah, okay. So, so since the 4 can be simplified, so what we're doing is square root of 3 times square root of 8 times 2. So that is equal to 2 times the square root of 24. And I don't know if I simplified that correctly because I'm pretty sure there's something more that you can simplify it down to. Because there's an 8. Oh, you can simplify the 8. I forgot. Okay, don't listen to whatever I just said. Oops. But, you can simplify this down to 4 and 2. So now what we're doing is square root of 3 times square root of 32, which is essentially square root of 8 times square root of 4, which is also essentially square root of 4 times square root of 2 times square root of 4. So you just move this here, and this represents the 8. So that means that the square root of 3 times square root of 4 times square root of 2 times square root of 4, and you can simplify those since those are just 2, and then 4 since you gotta multiply them, then 3 times, so yeah, there you go. I don't know if that made sense for you guys, but it made sense to me. So, yeah. Also, these are just problems straight out of the textbook, because I'm not coming up with them by myself just for a simple video. I'm literally studying for myself, not for you guys. So, you know. Next we have 1,440. I think you could just do square root of 144 and square root of 10. That's square root of 5, square root of 2. There's nothing else that I can go on. Okay, so this is essentially just 12, so that's 12 times square root of 10. And then we have cube root of 144 over 125. So what you really just have to find is the cube root of both of them. So like, if you had like the square root of, let me think, 81 over 121, that would just be 9 over 11, because 9 over 11 times 9 over 11 is 81 over 121. So yeah, so what we're trying to find is one fraction when multiplied by itself 3 times is equal to 144 over 125. Let's look at the solution, because I don't know what to do. Ew, what the hell? I mean, what the frick? No cussing in the classroom, guys. Okay, so 144 over cube root of 125 is equal to 144. Why factor it out? Let's move on to the second one. Dealing with a fraction, first simplify the fraction, then work on the numerator and denominator. So you have to factor it out. Oh, they simplified the radical first. Oops, that makes sense. Okay, so 144. Wait, that's just 12. What? 12. Oh, wait. Oops. No, because simplifying radicals, you have to... Oh, oopsies. Oopsie daisy, guys. Okay, let's just factor it out then. 2 to the 4 times 3 to the 2. What? That would be 9 times 16, which is... Well, I'm assuming it has to be this, because... Hey, let me erase. Okay. 4, 1... What? Wait, oops. I mean 5 and 14. Okay, yeah. I don't know how they did that though. Wait, let me see. So if 144, we have 2/4 times over 2. Can you just simplify that? Well, when simplifying, it's just 3. It's 12 and 12. And that's 3 and 4, 3 and 4. But how we get 2, 4 times 3, 2? Oh, this is not funny. Right? It's 12. Wait. Yeah. Okay, it's 12. Square root of 12 times square. Wait. It's 12 times 12 is equal to 144. So that means the square root of 12 times square root of 12 is equal to the square root of 144. Right? Yeah, okay. Oops. Sorry, guys. Brain fart. So how did he get 2/4? Or she? I'm not discriminating, guys. Oh! Oops. This can be derived into... I don't even know if I used that word correctly. Give me a moment. Obtain some... Yeah, I guess. Derived? Base a concept. They derived great comfort. Eliot derived his poetics from the French. Okay, what? I don't care. Okay, so this can be 2 and 2. And then these can be 2 and 2. So that means 2, 4 times 3, 2. Because there's 2 of these and then 4, 4, 4. Awesome sauce. So I was right about... I was right about doing the simplifying the radical. Okay, so we have 2, 4 times 3, 2 to the power of 1 over 3, because when you're finding the, so when you have like, dude, Siri, I wasn't talking to you. Okay, if you have like, let's say 7, because it's my favorite number, 7 to the power of 1 over 7, that is the same thing as the 7th root of 7 to the power of 1. And if you have like 4 to the power of 1 over 2, that's the same thing as the square root of 4 to the power of 1. So yeah. I just made a video on fractional exponents, the one I told you guys about, and how I forgot to, record my voice, and it's 23 minutes long, but it's okay. It's okay. Anyway, how did they know that though? 2, 4, 12? Oh, okay, so technically it's just saying the square third. Okay, awesome. Oops. Over, what bothers me? Over it, 1, 2, 5. Oh, that's so fun. Okay, 3, 1 over 3. And then, so you just distribute the fraction to the exponent. Exponents. 2, 4 over 3 times 3 times 2 over 3 over 5 times 3 over 3, which is just 5. Then what? 2 to the power of 1 times 2 to the power of 1 over 3? Where do you get that from? 2 to, oh, because this is equal to 2 and 1 and 1 over 3, and then when you're multiplying exponents, you add them together. Awesome! Okay. I'm kind of tired, so times 3 to the power of 1 over 3 times 2 over 5, that would equal, oh, now you can just take out the 5 because, well, if you just take out the parentheses, because it's kind of, well, look, since these are both to the power of 1, they can become their own fraction to the side, like that. And then you have another fraction. Hello? Okay. Now you have... This is not funny. Okay. Now you have 2 over 3 times 3 over 1 over 3 to the power of 2. Oops. And then you're gonna simplify that to a radical expression thing. So you do that, and then you do 2 square root of 3, I guess, times 9, because 3 squared, wait, I'll just write that out for you guys. Yeah, that. And then you can just combine them because they're both, yeah, okay. Yeah, 2 over 5 times the cube root of 2 times 3 squared, which is pretty much 2 over 5 times the cube root of 9 times 2, which is 18. And then you can't do anything else, so that's the answer. Great! Cool. let me just... I don't know if you guys can hear my mom talking in the background, but she's really loud right now. And that's not a problem with me, but like if you guys hear her and you're like, oh my gosh, she's like shouting and stuff, like is she mad? No, she's just talking to her friend. I don't know what they're talking about, but probably gossip. Anyway, let's move on to the next problem. I don't know how long this video has... Oh, it's been like 30 minutes. Oh shoot. Oops. Should I just end it? Yeah, I guess so. No, let's do one more problem, guys, because I'm seeing this problem in the... Oh, wait. No, that could be for another video, because it's rationalizing denominators. Ew. Okay. Thanks for watching, guys. Let me do my cool outro stuff. Thanks for watching. Then my outro music is a song that... Oh, what if I get copyrighted though? Actually, no, I wouldn't even make money off these videos because I've been talking too much. No one's gonna sit through that much talking. What outro song, guys? Love. Never knew what I was missing, but I knew what... Okay, bye, guys.